Okay, ladies and gentlemen, this will be the third and final video for the Graph Theory Terminology series, the first lesson of our Euler Graph Theory Unit. So here we see two more definitions and a new graph. Our new graph has 5 vertices. We have a set of multiple edges at BC. Notice there's 2 different edges there that have B and C for the endpoints, so it makes them multiple edges. We also have a loop at E, one edge that starts at E and ends at E. So anyway, adjacent vertices, this is a new term to our notes, are vertices which are connected by an edge. So connected, here goes here. Now, for example, in the graph, vertex A is adjacent to 3 vertices because it has 3 edges ending there. It is connected to vertex B, vertex C, and vertex D. So we would say that vertex A is adjacent to B, C, and D. Please pause the video for a moment and try the second example on your own. Name the vertices that are adjacent to vertex E. Okay, the vertices that are adjacent to vertex E, there are again 3 of them. The obvious ones are B and D. There are edges that connect E to both of those points. There's also a loop at E, which means that vertex E is adjacent to itself. So we would say that vertex E is adjacent to vertices B, D, and E. Now that's vertices. When we talk about adjacent edges, that is a little bit different. 2 edges are adjacent if they share a common endpoint. So, in this picture, edge AD, which is located right here, is adjacent to 3 other edges in this graph. At A, it shares endpoints with edge AB and edge AC. And at D, it shares an endpoint with edge DE, which makes it adjacent to those 3 edges, AB, AC, and DE. Now keep in mind, it wouldn't matter if those letters were reversed. You could say BA, CA, and ED. That is perfectly acceptable. So once again, please pause the video and attempt the second example. Tell me which edges are adjacent to BE. Okay, BE, which is the big loop here from B to E, or not loop, big arc from B to E, is adjacent to 5 other edges. It is adjacent to, at the B end, edge AB, and 2 edges, both of which are named BC, so we have to name all of those. And at the E end, it is adjacent to edge DE and the loop EE. So there are a total of 5 edges to which DE is adjacent. Now that idea is not nearly as important as this idea, the idea of degree. So here's that same graph, only now we're going to use it to talk about degree. The degree, and vertices are what we're talking about here, the degree of a vertex is the number of edges which end at a given vertex. So when we're looking at this graph, let's say we talk about A. A is an endpoint for 3 edges, AB, AC, and AD, which means that A is degree 3 because it has 3 edges ending there, which also means that A is what we call an odd vertex. It has an odd number of edges that end there, therefore its degree is odd, which makes it an odd vertex. At B, we have 4 edges that end at B. 1, 2, 3, 4. Which means that B is degree 4, and that makes B an even vertex. Now we can do this exact same process at every point in the entire graph. For instance, at C, we have 3 edges, 1, 2, 3, which means C is degree 3. D has 2 edges, 1, 2, So D is degree 2. Finally, E. E has a total of 4 edges. 1, 2, 3, 4, which makes E degree 4. Now, you may have just said to yourself, but one of those edges is a loop. That doesn't matter. Its ending, both ends are at E, which means that it gives E 2 for its degree. So there's a total of 4 edges that end, even though one of them is ending there twice. So if we look at this graph, B is degree 4, D is degree 2, and E is degree 4, meaning that B, D, and E are even vertices. A is degree 3, C is degree 3, meaning that A and C are odd vertices. The final thing I want to make sure I mention in detail, and I said this earlier in the unit, but I want to make sure it's formalized, is that everyone understands the idea of a bridge. I said earlier in the notes, somewhere in the first video, that a bridge is an edge whose removal causes the graph to become disconnected. So over to the left, you'll see a graph with 7 vertices. You take a second, pause the video, name all of the edges. I'm sorry, the bridges in this graph. There are 2 bridges in this graph, 2 edges who, when they are removed, the graph is no longer connected. Please pause the video and find those 2 edges. Okay, those 2 edges are edge AD. If it is deleted, then D becomes disconnected from the rest of the graph, like so. See, now D is no longer connected to the rest of the graph. That makes AD a bridge. The only other edge here that is a bridge is AE. If I remove AE, I have 2 clear components to that graph, making AE a bridge. This idea of a bridge is going to be extremely important down the road for us when we are doing Fleury's algorithm. Okay? So again, if AD is deleted, then D becomes disconnected. And if AE is deleted, EF and G are disconnected from the rest of the graph. That's how we know that those edges are bridges, because the graph is split into 2 components. Thank you very much for your time. Please make sure you complete the exit ticket through Google Forms. You'll have an assignment tomorrow, and tomorrow will be a day for you to complete that assignment. Thank you.